Okay, let's give you guys some more practice. So here I've got a wall here, and then I've got a mini wall here, and the distance between the mini wall here and the big wall here is 7 meters. The height of this mini wall here is 3 meters. The question is, what is the smallest, what is the shortest ladder that I would need? So I could have a ladder going from here to here, or I could use this ladder here from here to here. What is the smallest ladder that I will need? Okay, so you can lay your ladder like this, but this one's going to be really high up here. Okay, or you can lay it really flat over here. So ultimately you want a graph of the length of the ladder, length versus something. Okay, something. So L here is the length of the ladder. So you could vary this something. Well, this something could be you could vary the angle. So you could decide to vary this angle here, or make it really steep like this. So in this case, theta will be a lot bigger than this theta here. Or you can even vary the gradient of the ladder here. So you could plot a graph of L versus M, the gradient. So M here would be very steep, M here would be very shallow. Or you could vary the height. This height here. Well, there are lots of ways of doing this. Okay. So well, with me, I'm going to vary this length here. I'm going to call this X from here to here, and then vary it. It's up to you what you do, as long as you get to the answer. Find the shortest ladder. Okay, so press pause and have a go. Okay, so to do this here, you ultimately want you ultimately want a graph of length of the ladder versus something. But there are lots of ways of doing this. For me, I'm going to use X, where X represents the distance from here to here. Okay, so now well, translate the problem into this. So the problem earlier, I'm just going to flip it so that this is 0 0 here, and this here is 7, and the height of the mini wall here, the height is 3, and so on. So translate the earlier problem to this. Okay, so let's just say this is x0, and then we'll find out the equation for this line. Well, ultimately we want to find out the height here, the intercept. So once we've got the height, well, this here will be our x0 here. We need to know the height here in order to use Pythagoras, and then find out the length of the ladder. The length of the ladder. Remember Pythagoras, a squared plus b squared equals c squared, and so on. Okay, but we need to know this height here. So blah blah blah. The blah blah blah. So the height would be given by this. Okay, the height of this here. Hang on. The height here, as we vary x here, the height of this thing here will be 3 plus a tiny bit. Okay, well the height of this thing here is really the intercept here. Okay, the intercept of the straight line. So that height there is given by this. Okay, and then hang on. So the height is given by 3 plus a tiny bit here, and this tiny bit here depends on the location of this x0 here. Okay, so now now we can use Pythagoras now. So it will be this squared, so that's this thing here squared, plus this squared, plus that squared here, so equals L squared. L represents the length of our ladder. Okay, so from here, you can square root both sides. That will then give you this. So now, in a way, when you're here, you in a way have a graph of L versus X here. And remember that the domain for our X here, well, X cannot be less than 7. In fact, it can't even be 7. Okay, when you look at this here, hang on. When you look at the original problem, X it makes no sense for X to be it makes no sense for X to be 7. It just won't work. You can't have 7 7.0001, but you can't have 7, okay, and you can't have anything less than 7 because the ladder will be somewhere over here. But our problem is, well, the domain here has to be greater than 7. Okay, hang on, bear with me. So hang on, bear with me. So when you get to this stage here, square root both sides, that will then give you this. When you get to this stage here, you in effect have a graph of L versus X here. And then if you get a graph plotter and plot it, you would get something like this. Okay, and you will get something like this. When it's less than 7 or when it's less than 7 or equal to 7, we don't really care. Okay, we don't really care around here. So we can pretty much forget about this and just look at this. You can see that there is a value of x where the length of the ladder. Remember, this is length of the ladder. This here is our x. So if you make x to be really big, the ladder you will need a really long ladder. But there is a value somewhere in here where the length of the ladder will be at its shortest. Okay, but let's just pretend we didn't have this graph here. So we are currently here. Okay, so when you get to this stage here, let's pretend we didn't have this graph here. But yeah, pretend we didn't have this graph here, and I will continue in the next video. So we are currently here. Okay.